of moving the graph left, right, up, or down. So right here shows a sine function. Again, yesterday we did a sine b and then theta, which is x. This is going to be x. It says minus h plus k. If you remember that from circles, h and k was the center of the circle. H was the x and k was the y. So that's how it works here. It's the same thing. That's why we have these same types of equations. The h is going to move the graph left and right. It's inside of the parentheses, meaning it's with the x. Remember, think of that little theta sign as x. If you want to make it x, that's fine with me too. So this is x. So the h is with the x, meaning it's going to move the graph left or right. The k is on the outside. It's going to move the graph up or down. Again, inside of parentheses, you're thinking like you're setting these equal to 0. So a minus 2 actually means, just like in circles, a minus 2 actually means positive 2. So minus 2 would mean you're at positive 2. Okay? And then on the outside, that plus 6 means exactly what you would think. If it's a plus, then it's moving up. If it's a minus, then it's moving down. So you move it up or down. So let's look at example 1. In example 1, it says the sine of x minus 2 plus 6. And I want you to describe the transformations. And we can look at the graph, but we should really be able to describe it just from the equation. But I'll show you the graph also. So you go to, so I'm on Desmos y equals sine x minus 2 and then plus 6. So this is the graph that I end up with. Now, the regular sine graph is this. So what happened was, okay, let's look at what happened. What happened was the graph has now been moved. If you look at where 2 would be, it's right here. See, it's been moved over 2 and up 6 is what happened. So it got moved to the right by 2. So it moved 2 to the right, and then it moved up 6. So that's what you would say for your transformation for this. So the minus 2 right here is what takes the graph to the right 2, and the plus 6 is what takes it up 6. So that's what you want to put in for the first problem, for example, number 1.
So right 2 up 6.
Right 2 and up 6 is the transformation. Okay, in B, negative 2 cosine of x plus 4 minus 9. So we have negative 2 cosine x plus 4 minus 9. So we're going to look at that one. Maybe. So the x plus 4 means it is going which direction? Left. It would be at negative 4. So it goes left 4, and then the minus 9 means it's going on the outside.
Down.
Yeah, because the plus 6 took it up 6. The minus 9 means down 9. So it goes left 4 and down 9. Okay, and I'm going to show you what that graph looks like in just a second. But it goes left 4 and down 9. And that is over here. You'd be able to find, so the regular cosine graph is here. The one we're talking about is here. You should be able to notice something else about it. What does that 2 do to the graph? Yeah, it makes it bigger. It's a stretch. So you want to write that as well. It stretches it by 2. So we have a stretch by 2, and then it goes left 4, and then it also goes down 9. So the number in front stretches it. That's a transformation. Okay? So it's stretched by 2, goes left 4, down 9. Let's look at the next one. The next one is a tangent graph, okay? So it is, this is called, if you have a number less than 1, we want to call this instead of stretched, does anybody? Yeah, compressed. So it is compressed by 1/8. So we would say compressed. That means it's getting smaller. Compressed by 1/8. And in this one, don't worry about the fact that it has pi there. You see the minus, that means it's going to the right. So it's going to the right 5 pi over 2. So it's compressed by 1/8, and it moves right 5 pi over 2.
This is different.
So compressed by 1/8 and right 5 pi over 2. So I failed to mention that in B. You should have one other part of that. So in B, you have a reflection, that's the negative. Then you have a stretch by 2, that's the 2. Then you have a left 4, that's the plus 4. Then you have a down 9, that's the minus 9.
Wait, you have a what?
Reflection. That means it reflects over. That means it just like flips over.
So it's not stretch?
It is still a stretch, yes. The negative means reflect. The 2 is the stretch. The plus 4 is left, and the minus 9 is down. All right, example 2. Write the equation with the given translations. So we're taking sine, so a regular sine equation. So we take y equals sine of x. And we're going to change it to move it 3 units to the right and 2 units down. So we're going to say y equals sine of what? How do we move it 3 to the right?
Parentheses x minus 1.
Correct. And then 2 down.
Minus 2.
The end. Okay. You can always check your work on that and make sure that it matches when you look at the graph. Okay. So that's the key. Take a regular cosine graph. So y equals cosine of x. It says there's going to be a reflection over the x-axis. That's my negative. And then it says pi units down. So that's minus pi at the very end. So the negative in front gave me the reflection. And then that's outside of the parentheses. We're not even talking about the parentheses. If you want to put a parentheses here, you can. But on the outside is when we move it up or down. So this says it's going down by pi. So we just put minus pi. Lastly, we don't even deal with tangent graphs, but it's the same thing when we're talking about translations. You want to compress this by 1/4, so we'll take the original graph, tangent of x. To compress it by 1/4, we put 1/4 in front. Then we want to move it to the left 5, so we get to say x plus 5. That moves it over to negative 5, and down by 2 pi, so that would be minus 2 pi. And so there's our equation. So again, all we're talking about, so let's recap this. If you are reflecting something that over the x-axis, that is in front, that's the negative in front. If you're stretching the graph, that would be a number bigger than 1, right? That makes it stretch. A compression is a number less than 1. It's going to compress the graph, make it smaller up and down. If you're moving it to the left and right, that's inside of the parentheses with the x. So x minus something means you're moving it to the right. X plus something means you're moving it to the left. And then moving it up and down is going to be the number at the end. You're adding if you're moving it up. You're subtracting if you move it down. All of these, if you have any question about whether you did it right or not, you can always check Desmos and check the original graph and then check what you did and see if it moved in the right direction. And then if you did something wrong, you can fix that. Okay. If we want to graph 3 sine of 2 pi over 4, parentheses, and again, that can be x minus 2 and then plus 6. So we'll go to Desmos, we'll type in 3 sine 2 pi over 4. If I can get it typed in right. And then x minus 2 plus 6. See if I did that right. It doesn't look like it does. That would be a negative. Okay, so there we go. Now, what happened was, in this case, notice, it crosses the y-axis. It crosses the y-axis at positive 6. So that plus 6 moved it up by 6. Okay? The minus 2 moved the graph to the right by 2. I'm going to give you a regular sine graph. Let's type in y equals sine of x. So you see what happens. Y equals sine of x is usually right here. It's moved this graph, it's moved it to the right by 2, that minus 2. The plus 6 has made it where instead of crossing at 0, 0, it crosses at 6. And then you see these are much taller. That's the 3. The 3 is the stretch. That's the amplitude that we talked about yesterday. So it's going up 3. That means the highest it gets to is 9, right? And it's going down to negative 3. Now, how do I get, so the period, see where it repeats, is 4. So it goes from negative 1 to 3. The next one will be at 7, then at 11. How would I get that? If you remember, the period is 2 pi over b, and we already talked about what b is. So b in this one is 2 pi over 4. So if you did 2 pi divided by 2 pi over 4, that would be pretty simple. This is your b. So 2 pi divided by 2 pi over 4, that's the same thing as 2 pi times 4 over 2 pi. So what happens is the 2 pi's cancel out. So your period is 4. That means it repeats itself every 4 numbers. So it's at negative 1, at 3, at 7, at 11, and so on. So again, it's moved. There's a lot of things to know about a graph right there that we have. We have the 3 showing us the amplitude that it goes up and down by 3. We have the period being 4 that we can see from there. We have that it's moved to the right by 2. We have that it's moved up 6. We've got all kinds of things going on with that graph that you can see. Okay, all you have to do is be able to just see it and how the numbers affect the difference in this. If we take the 3 away here, notice it's not as tall. If we take the minus 2 away, notice it moves back from the right, moves back over. If we take the plus 6 away, notice it's now back down at the bottom. So you can see how everything affects each part of the graph. All right, so let's go to the last one. Negative 2 cosine of pi over 3, and then x minus 1 plus 2. Okay? So negative 2 cosine of pi over 3, and then x minus 1 plus 2. So there is my graph. If you take a look at this graph, notice it crosses at 1. There's a reason for that here in a minute. But what happens here on this graph is the negative has flipped it across the x. It reflects across the x-axis. But then I've moved it up 2. So after I reflected it like down across the x-axis, it then moved up 2. So now it's back above. The 2 is a stretch. So that just means the amplitude is 2. The lowest it goes is 0. The highest it goes is 4. So it's a stretch by 2. And then plus 2 means, think of the middle of this graph, right in the middle. That's at positive 2. Normally, a cosine graph would be down at 0. So I can show you what the normal cosine graph looks like. That's what the normal cosine graph looks like. Look at how it's flipped. You see how it's flipped? If you think about that normal, the purple one, and you just flip it, that's the flip. The 2 is the stretching it. The x minus 1 moves it 1 to the right, and then the plus 2 has moved it up 2. So those are all the differences from the regular cosine graph. So you can see all the transformations that are happening. If you take away this plus 2, it's now down there. If you take away the negative, it's no longer flipped. If you take away the 2, it's now not as tall. If you take away the x minus 1, it now moves back over. Okay? And then if you take away this, it looks like your regular cosine graph. So all of those things affect how the graph moves. Up, down, left, right, stretching, reflecting, all those different parts. So that's translating a graph. And it doesn't matter. This is good to know for everything because trig graphs, sine and cosine graphs, moving them left, right, up, and down is the same way you're going to move a quadratic. Okay? So in math 2, when you talk about moving a quadratic back before math 3, same thing. Left, right, up, and down, stretch, compress. They did the same stuff. You're doing the same thing that you've done in a previous class, but now you're doing it with a sine and a cosine graph.